Good morning. The purpose of this video is to walk you through the notation and the difference in 5.4 from the rest of the stuff we've been doing in Chapter 5. So I'm using the slides. If you want to pause this video and print the 5.4 PowerPoint slides, you're welcome to do so you can follow along with me. So in 5.4, we're going to look at sampling distributions and what in the world is the central limit theorem. Our objectives here are how to find the sampling distributions and how to apply the central limit theorem. So a sampling distribution is the probability distribution of a sample statistic, for example, like X bar. And it's formed when samples of size n are taken over and over and over again from your population. So it is a sample of the sample means, so to speak. So the book does this cute little picture, but you have a population with a mean of whatever and a standard deviation of whatever, and you take all these different samples. They're all the same size, and you find all the averages. If you were to average the averages together, which is exactly what this says, the mean of the sample means, so however many samples you take, so in the previous picture they took 5, but you have these 5 sample means. If you did this enough, often enough, the average of all these averages would actually be the mean of the population. The standard deviation then is found by doing this. So this would be the standard deviation of the average of the means, okay? And it is the standard deviation for the population divided by the sample size you're taking. We also call this the standard error of the mean. So if we're going to talk about the average of the averages, so that's written mu of X bar, it would be equal to mu. And if we wanted the standard deviation for X bar, we would do the standard deviation of the population divided by the square root of n. So these are our two big components in 5.4. So we have two new formulas. So this next problem says that we're going to look at values 1, 3, 5, and 7 and we put them on slips of paper. And we only pick 2 pieces of paper. And then it says, find the mean, the variance, and the standard deviation. So, this is stupid. But we're going to walk through it anyway. So the population values 1, 3, 5, and 7. If you wanted to find the mean, and they just magically come up with this number, but they took all the x's and they came back and divided by 4. And that would give us the mean of the population because we only had 4 things in our population. You can find the variance by using this formula, and then the standard deviation is what we need. On the next page, what they do is they come through and they look at what's the probability of drawing each one of these. Well, each one of these has a probability of 1/4 because it's 1 out of 4. And then it says, what are all the possible sample sizes? So we have these 4 slips of paper, and these are all the different ways we could sample with a size 2. So these are the means. So then they've come and they've calculated the means right here for each one of the samples. So if I were to average all of these together, it should equal 4. Now they're constructing a probability distribution because they have nothing better to do with their time, and yes, I said it. And they come through and they show you that this actually works. So yee-haw for them. We're so proud of them. And they graph it. And if you notice, the graph is symmetric and bell-shaped, and it approximates a normal distribution. So how awesome is that? So here's our central limit theorem. So they go through